In the next few videos, we'll explore a concept called integration. It's the opposite of differentiation. What do I mean by that? Is you might recall that the derivative of, say, x cube is 3x square. So then, if I were to integrate 3x square, I would get x cube. And that's what I mean by anti-differentiation. It goes in the reverse direction. And we use this elongated s symbol for integration. And I would write integral, and we read it as integral 3x square. And when you differentiate, you write d over dx. For integrals with respect to x, you say 3x squared dx. Now this happens to be equal to x cube. But notice, I could have the derivative of x cubed plus any constant would give me 3x squared. So I can write that this is x cubed plus c. So that's the idea of integration. It's trying to find a function whose derivative is your given answer. So if you're trying to find the integral of 3x squared, you're looking for all those functions whose derivative is 3x squared, which means it has to be x cubed plus c. Just like derivatives, integration will also have certain nice properties. So one of the things we saw is that the derivative has sum and constant multiple rule. So let's write down that the derivative of f of x equals lowercase f of x, which means if I differentiate some function, I'm getting lowercase f. And if I differentiate uppercase g, then I will get lowercase g. So the lowercase denotes the derivatives and the uppercase denotes the integrals. Now notice, if you have to differentiate the sum of f plus g of x, so f of x plus g of x, this is simply the derivative of f plus the derivative of g. So that's going to be simply f of x plus g of x. So notice, if I were to integrate this, I get that, which means integral of f of x plus g of x and is going to be same as the integral of f of x with respect to x plus the integral of g of x. Now the rule does not change if I replace plus with a minus. So that's the sum rule for integration. So let's call it as the sum slash difference rule for integration. So this is called the sum or difference rule for integration. So this allows you to integrate several terms. If your function has more than one term, then you can simply think about integrating a single term at a time. Now, the derivative had the constant multiple rule, so let me just rewrite that. So derivative of c times f of x is c times the derivative of f of x, which is c f of x. Now notice, if I were to integrate this, I'm going to get that. So integral of c lowercase f is the same as then c times f of x. So that is c times the integral of f of x. So just like derivative, you have the constant multiple rule as well. So let's call it as constant multiple rule of integration. Now, those were some similarities. And then, but the derivative has a lot of nice properties, but we don't have those for integration. So something like product rule, quotient rule, chain rule. I mean, those sound as rules, but they're really trying to help us. So I would like to call them formulas. We have product formula, quotient formula, and chain formula for uh, derivatives, for differentiation. We don't have anything like that in integration. We have to go around. If I want to integrate a product of functions or a quotient of function or a composition of functions. We will look at more properties of integration in subsequent videos.